Hello guys, welcome to yet another episode of AML Talk. So today we'll be talking about how we can use fine tuning to improve our RAG models. So in our previous videos we talked a lot about RAG models and how we can use our own data to get create our own chatbot. So today what we are trying to do is we'll try to fine tune a large language model using our own data sets, and we'll see how we can improve the accuracy of our models, how we can get the correct answers for any of our queries based on our own data sets. Okay, so let's move to the code part and see how fine tuning works in large language models. Hello guys, so let's move to the coding part of it. So the first thing that you need to do is you need to have Colab, and the Colab you will be using GPU. So Colab has GPU, like normal systems doesn't have the GPU. So in Colab, to use GPU, you will just go to runtime and then you do the change run type, and the free tier will have T4 GPU, L4 GPU, and 800 GPUs are there in the Colab Pro version that I'm using currently. So I'll be using 800 GPU just for the sake of it, because it will be little bit faster for me to use it. So the first thing that you need to do is you need to install the transformers, datasets, torch, TRL, PEFT, and bits and bytes. So one more thing, in Colab, you can go here and check the resources, right? So you will be checking that how much GPU RAM at any point of time you are having, and how much it is using as of now. Okay, what is the system RAM that is using, and what is the disk size that is there. Okay, so you can just close it out, and then you can uh, run it out. So basically, I'll be installing all this. So all of these are already installed, so it won't take that much time. It is already satisfied. So once that is there, so we will just try to see how DeepSeek 1.5 is performing on a particular text. So basically, it will download the DeepSeek model from Hugging Face, and from there we are just trying to generate the response. Okay, so this is a basic template for any. You can use it as a basic template. So basically, this is what will be given to you in Hugging Face. So from there, you need to import these transformers and torch, and then you need to create your own generate for text function, in which we need to give the prompt, what is your prompt, and then you need to mention what is your temperature, what is your max length, all those things you need to mention. And so I will just show you how the bare basic thing works, and then we will show you how it will work after the fine tuning part of it. Okay, so let me just work on it, and let's run the first part. So we are giving two prompts, and we'll see DeepSeek 1.5 version, that is a digital model, how it will work in this particular scenario. Okay, so it will take some time to load the configuration, and the configuration is the model part. Basically, it will download it from there. So it will take a bit of time. So let's wait for it, and then it will take some time to generate the answers also. So this will take around, I guess, a minute or two to download the model. This is a small model, that's why it's only 3.5 GBs of it. Otherwise, so what it will do, it will create a new the models will be saved in your Colab instance, and once we restart the instance for any reason, so all of these will be gone. So we need to again download it. So just remember this thing. So Colab, if you are running a model, you will have to somehow or the other restart it. If there is any issue for restarting, then you will lose your model. So you then again have to do the same process. So this process will be going on every time that you use any model for inference in Colab. So keep that in mind, and that way we can prepare ourselves. So if you download it locally in your CPU, then it will have, if you're doing it in Jupyter, then these models will be saved there, and you can do an inference right there itself. Okay, but in CPU we will not be able to download this much this sometimes it happens that the inference part is a bit slower because it's it's not parallel processing out there. So see, the first prompt that we have come to this part, so we are printing the prompt. Now the generate text is taking some time, so let's wait for it. So it will just give some garbage values as of now. That's what I have seen. So you can see that we have got some garbage value out there. So in the Buddhism, at least it is trying to give some answer. Okay, it is just trying to check from where it has got the text, wherever it has matched. This tell me about what are the key points, what are the, so just it is trying to at least do something. Okay. So it is just repeating the same thing. Okay, and the in this Buddhism part also, what are the major religions and all those things. It is just repeating it n number of times, but it is not giving any specific answer as of now. So this model is not that good for text generation part. So we'll try to see whether our fine tuning improves it or not. So what will happen if we have decent amount of data, because I don't think this is instruction fine tuned in a better manner. So we'll see how it will work. So see, in this portion also, in yoga philosophy, what is the significant concept of isma of non-violence. So what I have done is, so I have taken a data set. So this data set is, I'll just copy and run it. So this is from an Hugging Face dataset. So this is having a very small 616 column only, in which the instruction is given, and then there is an output of it. Okay. So same thing. Uh, so the in Jainism also, what are the four noble truths and the eightfold path. Okay. So this is what it is. So what we will do is we will load our data first from a Hugging Face data set, and then we will using LoRA, we will fine tune our model, and the model that we are going to fine tune is basically Deepseek R1 Digital Quen 1.5B. So the configuration of LoRA is so we have taken a R of 16, and then LoRa alpha of scaling factor is 32, and then LoRa dropout factor that we are taking is 0.1. And as of now, we have taken bias as none, and then task type we are we have taken a casual learning model. Okay, and then task module, we can reduce the number of target modules also here. So the based and apart from that, what we can do is, what we will be doing is we will be formatting this dataset. So this dataset currently is not in our format as of now. So we need to format into uh, text format. So basically, I can print this text also, and we can see. So what we are doing here is basically we are whatever response was there in instruction and output, I've combined both of them in this thing in this format, and we have appended it out here. Okay. uh, so and then we have just formatted this data set. Okay, and then we have loading the model in the tokenizer, and then we are just giving our PEFT config, that is LoRa config, and the model will be based on PEFT config only. Then after we need to define our training argument. So basically we are going to save the results in the in the output directory will be results, and the number of epochs that I am trying to do is 15. So I'll just maybe increase it to, let's say, uh, make it somewhat around, let's make it 20. Okay, and then batch size and evaluation batch size, that also you can this gradient accumulation steps also you can increase if you want to reduce the training time and all. So that's how you can do, and then you can mention the Adam optimizer, what is the learning rate, depending upon your use case. If you want a faster training time, then you can reduce the learning rate. If you want a better like training, then you can decrease the learning rate and see how it will work and all. So we are using as of now FP16. Okay, so, and we are logging every 10 steps out there, and every 100 steps we are saving it out. Okay, so then we will give the like SFT trainer. So this is my the last run. So this was my SFT trainer. So we are passing the model and the training argument. So training arguments we have defined it here, and what is the training data set and what is the evaluation data set. So basically the data that we have is of 6 to 12. So that's why I'm taking a evaluation range of 100. So we can make it around 120, so 20% sort of will be our evaluation data set. And then we'll train the model. So let's see how it will take some time, like to run this model. So once you start training this part, what will happen is it will keep on start training this file, and the epochs are a little bit higher, so it will take around. Okay, there is some issue, Hugging Face. Okay, rare timeout error has come up. We'll see what has happened. Again, let me try it out. There is internet issue, I guess. Yeah. Now, yeah. So it has read all of these, and now it is the trading has started. So see the training has started, and it will take around 10 minutes of time. It is showing right now. So we can keep waiting it there, or I'll just fast forward that part. We'll move directly what was the results and everything, and we'll see okay how that comes, and then we will save the model, and then we'll see the final result of it. So as you can see, our model training has been done, and now we have done our epochs, and we have received the training loss and validation loss. So the training loss and validation loss was decreasing with time. We could have kept more epochs, and this would have kept on decreasing a bit. So we have just used just for the sake of giving an example how you can do it. So we can save this model right now. We can save this model to our location. So this our location is Finetune Deepseek R1 1.5B. So we'll just save it there. So this tokenizer is saved, special tokens dot map is saved, and then tokenizer dot JSON is also saved. Now what we can do is again we can then run it out there and see what's the output that we are getting. So let me make it maybe 1000 and see. So I'm using the same code that it was used here. Okay, in the first part I'm just using the same thing, and uh, we're just changing it a bit for our a use case. Okay, so let's see if I make it top 10 a little. Okay, yeah. So now let's run it out. So it takes a bit to run this particular give you the inference, but in a real use case, uh, you'll have to have a better inferencing time. Otherwise, your model will not be used in production. So right now we're just using Hugging Face models, and our server is an A100 GPU that I'm using. So let's see how much time it is taking. Normally it takes around uh, 30 seconds to 1 minute. So let's see how much time it is taking to generate the answer, because this is a reasoning model, so it also takes some time. Otherwise, we'll get the answer as it is directly from this if it was a non-reasoning model. Okay. So maybe I'll just skip this part to the final answer, as it is taking some time for the generation. So let's move to it. So as you can see, the still the answer that we have got right now is non-significant right now, because it's just repeating the same garbage here and there in the context of yoga. What is the significance of INSMA and non-violence? So what we need to do is we need to keep on changing this part. Like, we can try with several things that we can do. We can at least, for this particular use case, what we can do, we can increase the number of epochs. We will try it out. So what I'm going to do right now is trying to, we'll go and change the number of epochs and train on a higher number of epochs, so that we'll get a better answer. Okay, so let's move to it. So in this part we had epochs of 20. So what, let's do one thing, like let's make it 200 and then train it out, and we'll see how our model responds to this particular change right now. So let's start the training run for this 200, and it might take some time. It will take a huge amount of time, at least, and then we will see how it works. Okay, so yeah, now we can see that it's almost over here, and we have got the final run here. So the final step error that we have got, this is the training error, and this is the validation error that we have received. So now what we will do is we will see whether our accuracy has improved or not. So let us save it here. Yeah, see, this is what I had already run it. So now this is what it is giving. So let's try to rerun it again. So now we will see it is also thinking, and it is also giving us the final uh, answer. So let's see. Uh, it takes a bit, but yeah, it will give us the answer. So see, what has happened is, yeah, in yoga philosophy, what is significance of concept of ahimsa? What does it is saying that in yoga philosophy, ahimsa or non-violence is the fundamental principle that emphasizes the avoidance of causing harm to others. It is the practice of cultivating compensation, forgiveness, and all those things. So now, when you see the answer, so answer here in this scenario was like a garbage, the complete garbage, right? So now we have received a better answer. So that what tell me